session, so you can so the session is muted now, and I will also share my screen. So today we will work here, but as usually we will work then on during next sessions we'll work using Google Meet. Alright, so as usually, welcome everyone to our new course. It's not January, but March. As usual, we'll start with agenda, and I will, as usual, I will share all the files with you at the beginning of the lesson. But this time I will do it a little bit differently. I will put all the agendas and materials. I created a new text channel, so I hope that you all can access this channel. You should be able to see my screen. So hope you all will, you all are able to access this channel. And just to not have everything in the same channel, I will put all the agendas we have and all the materials under this channel. So you can easily search and find the materials here in case you have any advices. How can we improve our structure? Please let me know. But for now I will put all the materials here and the agenda as well. So hope again, please let me know if you can't access this channel. So I will try to help you. And all the materials here as well. Alright, so materials will be here, but for the discussions we'll use our same general channel. For those who was not with us, we use Discord for all the discussions. So we have this Discord channel. All the discussions will be here. Again, if you have any questions to me, you can also contact me using Discord. Write me directly or write in our general chat, and here we will discuss all the things we have. As you know, as I said, we will have the meetings in Google Meet, or just as we have here right now. Usually we don't ask the questions directly from the meeting, just to make the queue of the questions. Because sometimes there may be the queue of the questions, so everyone wants to ask something. That's why it's easier to ask the questions here. So you can ask the questions here, and during the session I will answer to them right here. So that's about the questions. In case you have any questions, please ask here. So that's about Discord. All the materials will be stored here. Any questions, please ask me publicly, or you can privately ask me as well. So this is about Discord. I hope I mentioned everything about Discord. Then all the sessions, as you know, the same as previously. All the sessions are recorded in YouTube as private stream. So just at the beginning of the lesson, I start the stream, and basically our session is streamed here on YouTube. So you can easily find the recording of the session on my channel. So for those who doesn't know the channel, I will share the link to the channel where you can find all the materials we have, all the recordings from all the sessions. So one moment, I will quickly share the link to the channel where you can find all the materials. all the recordings. So I hope that this one is the right one, the right link. So if you can't access using this link, please let me know. Yeah, so this is about YouTube streams. Maybe let me think a little bit. Just okay, since we are on YouTube now, so I can also show you one thing. Basically, I had this course already last year, so you can find most of the recordings we will have now. I will add some details to our course, some new topics we will discuss. I will let you know what these topics are, but you can find the videos, the recordings I've had from this course we have now, which was last year, so it means until Java-13. So all these videos belong to this course. So in case you want to check different recording, then I will speak to you. Maybe something will be different here, so you can easily check the recordings here as well, additional recordings. But again, as I just said, there will be something new. The structure will be different a little bit. That's most likely we'll have new tasks here, also some different materials. So something will be different. But in case you want to see additional recording, if you just have something unclear, if something is unclear for you, so you can easily check these videos as well. Alright, so that's about it, about the organization. So I think then we can start our course. Right? So first let me introduce the agenda for you for today. So today we'll have the introduction session. I will explain you the main details about the course. I already explained some things about the structure we have, but there will be some additional things I will mention to you as well. So first of all, we will start with the presentation, where I will tell you the key details about the course. After that, I will introduce you to AutoWeb. That's the place where you can find all the materials we need for the course. Technical materials and some videos as well. You can also take a look on, and then we will have an introduction. It's introduction to Java, but that's not just like the main introduction we had before, but with some additional things which will be used in this course. And finally today we will set up our project. So that's the Java project in Eclipse, not on Eclipse, but in any IDE you want to use. So we'll set up the project, Java project, where there will be all the tasks we'll have in this course. And I will explain to you, but all the tasks will be placed in the same project. Alright, so now let's move to the presentation. So that's the introduction to the Java. We will use the key points of the Java we will use in this course. So let's start. The agenda for this presentation is we'll talk about some design principles used in Java, main Java benefits, technology stack. I missed to introduce you to the main course. Sorry. This is the first presentation. I'm so sorry. So firstly, let's discuss the details about the course we have. So that's the goal of the course, some key details about the course, and the results we can expect at the end of the course. So first of all, the goal of the course. The goal is to provide theoretical knowledge and practical experience. It says in software engineering fundamentals using Java as programming language. I would say we will also use some non-Java things where Java is used, can be used. That's mostly if we go a little bit ahead now. So that's mostly related to web development. So I will introduce you with some key things about web development. So it means that we will go maybe a little bit out from Java, but yeah, we'll use Java here as well. But there will be some things which are not directly related to Java. I mean HTML. So we'll using which we can build the websites, the framework of the website, the template of the website. Then the CSS, the style of the pages and website, and JavaScript. Please do not mix JavaScript with Java. JavaScript, that's a totally different language. It's unfortunate there are lots of people who mix these two languages, but these two languages absolutely are not linked to each other. Maybe only the prefix Java for both of the languages, but Java is not the same as JavaScript. JavaScript is used for some runtime controlling in websites, in web pages, but Java can be used for the backend. Yeah, we will have the discussion what the backend means and what the frontend means, what are the differences between these two. But yeah, we'll talk about HTML, CSS, and JavaScript, and how Java can be used there. But in this case, we'll go a little bit out of Java in these topics, because we need them to be able to understand how the software, how the web development can be done. So yeah, and here you can see the main topics: Java as programming language. Some things we'll repeat some things about Java programming language from what we already had. Also with some additional features, some additional points here. Then also we will explore more object-oriented systems. We'll have the analysis of them, software design and programming, so how the objects are used in Java and in programming in general. So in this course I would like to point more not only on Java as the language itself, but on the programming, let's say objects, programming features in general. So yeah, that's because these things are very important in programming, and not only in Java. Because in previous course I mentioned that if you understand the main concepts like object-oriented programming, variable declaring, loops, functions declaring, exceptions. So I would say in most of the programming languages, all these things work in the same way. Maybe with some differences, but in general, if we talk about object-oriented programming, it means that all the references, the changing of the references, the variables where the references are stored, work the same way. So in this case, we will talk about these points as the subjects, not only in Java but in general as well. Alright, yeah. Then we'll have the development environment and configuration management. That's also the part. Then web development, as I mentioned, I would like to point to use web development, because in my point of view that's maybe very interesting for you if we build some web things, say also web applications, maybe a little bit of a kind of website, because we don't really have so much time to build the whole website, but some elements of the website we can build them, and we'll see how can we do it. Then yeah, collaboration using version control system. That's about we already used Git. So you know some basic things, how we can push or fetch the changes. We will also take a look on the branching. I mentioned it in previous course, so a little bit about it previously. Yeah, in previous course we just use one branch. In this course we will use several branches. We will talk about how to use different branches to deploy the changes to the remote repository, and of course to use Git locally as well. Then yeah, at the end of this course you will have to work in teams. So previously you worked in teams of 2 or 3. In this course there will be larger teams, comparing to the previous course, here you will have firstly like more advanced task, and also the way how you work in teams. So previously I talked about Agile, Scrum, ways of project working, methodology of project working. So in this course you will apply these approaches to your project work. So you will work like in real life, like the projects happening in real life. So that will be as a practice in teamwork. Then yeah, also as a part of working teamwork, you will find knowledge to define roles and assign tasks to team members. So the work will be split in the project. And yeah, also the fundamentals of software engineering, project life cycle and management approaches, also as a part of the project management here. Yeah, so about this course is based on Global Perform Java Bootcamp in Accenture, developed by Massachusetts Institute of Technology. So this is 160 hours course. Comparing to the previous course we had, here there will be more tasks. The tasks I would say would be a little bit more advanced. Some of them will be tricky, but there are some points which will make it easier for you and for me to understand if tasks are done correctly. But yeah, I will show you this feature a little bit later when we set up our project. So the materials of the course may be found here. So maybe I will. I think I can already introduce you with Odo LV. So basically, the course will have during our 160 hours will be this course. With some differences. First of all, let me quickly check. We will skip, most likely we'll skip, but if we have time we can take some of the topics as well. So I think most likely we'll skip unified modeling language, UML, shortly. Then Y4 threads, networking as well, and unit testing, GUI applications, and also I think we'll skip Android development, but we'll see. Maybe some of the topics, if we have time, we will take some of these topics. That's about these topics. Also there are extra exercises, and these are extra topics. We'll definitely take a topic about XML, JSON, advanced language features. We'll also take advanced language features in this course. I think we want to take JPA, software design patterns. Also don't think that, but we'll see about this one. Log4j, I think we'll take this one as well. Then some features of Java 8, maybe yes, but most likely not. We'll see about this one. Then Java native interface, also not sure about this one. I think this one will not take. Multi-threaded networking, also don't think so. And Java building tools, partially. We'll partially take because we'll use Maven, which is part of Java building tools, and this is the one we will set up this week. So here we have the topics. We'll mostly go one by one. About extra exercises, extra topics, I will include them somewhere here. We'll see when. Some things, I think I have some custom presentations prepared by myself. I'm not sure, but I guess so. If I have some custom things, I will also share all the custom presentations created by me as well with you here. And under each exercise, under each topic, you'll have. Let's start with just to show you. You have the presentation. This is the base of the presentations we have. Mostly the content will be of these presentations will be mostly the same, but some things are changed and some things are added as well. So there may be some differences. Also, maybe time by time I will add some details as well. And you can also find the videos here as well. So these are I would say shorter videos, shorter lectures of the topics explained, and the explanations in these videos are explanation is a little bit more complicated than I will explain to you. But in case something is clear for you, again, you can also check these videos as well. That's about the videos. The presentations will mostly be the same here, but a little bit different. And also, here you have the explanation of the practical tasks. I will show you what kind of tasks we have. We'll see these tasks during the preparation of the project. But again, the idea is that you can read the definition of the tasks under these sections here. That's about it. Also, we will have 2 tests during this course, somewhere in the middle, and we are at the end of the course. Then there will be 2 tests here, and comparing to the previous course, in this course I will put the points for the home tasks done and for the tests as well. So at the end you will have the result grade you have. And that's about the materials and the topics we have. Preconditions. You should basically, I think all of you already work with all these technical things. So in this case, I think that everyone has good skills in workstation usage, like power usage. You can openly browse at the internet and so on. These basic things. Understanding of general understanding of operating systems and programming languages. If something is missed by you, don't worry. We will talk about these things. Then optional knowledge, which can be very useful for you. A general understanding of OOP, object-oriented programming principles, and general understanding of version control. Again, this is about Git, what we previously used. In this case, in this course, as I said, we will take a little bit deeper in it. We will go a little bit deeper in this topic. We'll explore some more things. At the end of the course, you will be able to program in Java, to work with some with external systems and libraries. You can use Eclipse as development environment. Understanding of version control. You'll have the understanding of version control principles. This is about also getting code changes into shared version control repository. Understand the concepts of object-oriented programming. Previously, we already worked with some key things. In this course, we'll work more. Also, there will be one task. Maybe I just before we start, there will be the task in the 5th topic. Previously, sorry, not here. Next moment, we can quickly check. I think that should be the 6th one. That's the 6th topic. Right here, there will be one task about object-oriented programming, which was so confusing for most of the participants in my previous course, because there are some tricky things here which can be complicated. So this time I will try to explain some details before we start with this task. But there were some interesting things about this task. But from my point of view, some things from such tasks will help you to understand the general concepts of object-oriented programming and how can we use them. So this is about object-oriented programming. We'll have, I think, lots of interesting tasks, and these will help you to understand some concepts used in programming. Then also the concepts of web development, as I already mentioned, life cycle of the project, as I already mentioned, project management, how to manage the project, what are the roles in the project, how you can work there. You can split the work. and also you will be prepared to make contribution to other colleagues, help them solving problems, can work in different software engineering projects and switch to other programming languages. As I mentioned several times, it's also really important to be able to switch to different programming languages if needed, because you never know which language you will need. For example, you work in the project, you join the project, and the members of this project, as a part of the design of the solutions they have in the project, there is Java maybe as programming language, and some I would say foreign, integrated or foreign things are written in different languages. For example, they mentioned about SAP. So in SAP there are lots of products. Some of them, for example, SAP Hybris is written in Java. It uses Java, and so in this case there's Java used in SAP Hybris, but there are different other SAP systems which can be integrated with Hybris system, and these systems are written in other programming languages, like C. For C has its own language, ERP systems like ECC, CRM, or S4HANA, they use ABAP, Advanced Business Application Programming, as the programming language. There are lots of languages. Also JavaScript as a famous language is the key language is used for front-end development. Java also is used for some calculations there. So in this case you work in the project, there is Java, but you will face some different products as well, which require other programming languages. So in this case I would say you should be flexible to be able to, I would say, not to understand at the beginning, to be able to start just coding or use other programming languages, but to in general to understand the languages. But we will talk about it. In case you get disappointed, because this course I would say is quite technical, with some technical tasks. Also from previous experience in this course, some participants were scared about some technical things, so I would say to you, don't worry, please. Don't in case you have any questions, just if the questions are quite simple, every time please ask me. I'll try to help you. But in case something is you feel that something is going wrong, again, in IT world there are lots of positions which do not require you to know everything from coding, like the project management. There are people who don't work with technical things, but just with organizing or to organizing, lead the groups, lead the teams, and the project in general. So these things do not require you to be quite a technical person. So don't worry in this case. The speed of the course, we don't plan to be so intensive, and all the tasks can be described as hard but doable. I will try to give you enough days to complete the tasks. So don't worry and don't hesitate to ask for any help. As you already know, I will always try to help you in case you have any questions. And it is found that most of the students will complete the tasks. So it means that some students will not be able to complete some tasks. Actually, unfortunately, there were some tasks, maybe one or two. I think that only one task from all the tasks we will have in this course. I think that was this one I already mentioned, or something, or different task. I don't actually remember, but yeah, there was one task which no one from the students was able to complete, but I hope that we'll try to manage to complete all these things this time. So also please complete before deadlines. We'll discuss all the tasks in class. Also, I will try to prepare you before tasks for the upcoming task. And also maybe something is partially done, that you will also get a fraction of credit, of points to your task for the task. And some tasks may be described as easy credits. Most of these are first tasks. So you can complete them, and as you already know, the course schedule, we'll all work on the same schedule. There are two lines of tasks, regular and extra, as you can see from here, and we will see from basically the list of the tasks, from the project of the tasks we have. I will explain you, but in this case you will see extra tasks, but most of these tasks will also be considered as the main tasks. So regular and extra tasks will both be considered as the tasks to be done, because there are some different topics in regular and extra tasks. So I want all these topics to be discussed. That's why we will go through extra activities in the same way as we go to the regular activities. But as I said, some of them will be skipped, and I will notify you which to be done. Alright, please do not rush. Go ahead of schedule, plan schedule. If you have such wish, such role, you can do it. It's not prohibited. It doesn't need to be bored. In case you completed the regular tasks, you can take some extra tasks. If you already done with the extra tasks, you can ask me for more. I can give you and all the tasks will be rated. You can improve the code solution if possible. So we had in the course before. So some things, some best practices, I will also check if all or most of the best practices are applied to the code you submitted. And also in this course, in addition to these topics, I want to prepare. I had this thought right now. We'll see. I also want to prepare some things about best practices, some materials about best practices used in programming. You can apply in your code. in Java or anywhere else as well. And yeah, you can work more, and it's not prohibited or encouraged. That's up to you. Okay, right now, as you know, we'll have 2 breaks during each session. So right now, let's have 10 minutes break, and after the break, we can continue. Okay, let's move on. So that's about the course schedule, and the next one is about the scheduler of the course. We have, like you can see, we have Saturdays here. There's I think this one is also shared by Zander with you, but not sure about it. But anyway, so yeah, about Mondays, regarding Mondays, Wednesdays, and Fridays. So yeah, that stands as it is here. And about Saturdays, so we will have not from 9 to 3 p.m. but from 9 to 4 p.m. or to 2 p.m. 2 p.m. That's 5 hours. But these will be like more in the say not in freestyle, but without rush. Some things will be optional to this. Some optional discussions, mostly. We'll have some main part of the sessions, but also the part of these sessions will be just discussions. So to not make it hard to everyone on Saturdays, not rush. And also, in addition, there is one. There is more Saturdays than it should be. So there should be. So there are 1, 2, 3, 4, 5, 6 Saturdays, but there will actually be 5 Saturdays. So one will skip one of these. We'll see which one, and we'll see. We'll see which one to skip. This Saturday we'll have the session, but about upcoming Saturdays we'll see which one will be skipped. So there is one extra Saturday just in case some lessons will be skipped, but we'll see which one and how it goes. In general, one of these will be at the moment. Yeah, we can find that one of these will be skipped. We'll see which one. Just one is scheduled as the reserve. Alright, yeah. So this is about the scheduler. And yeah, support levels. And we are working in material-rich environment. So something you can you're not sure about. So in case you have any questions, please ask me or ask anyone else. Just ask. Do not get stuck with some complicated things here. Yeah. So the last thing before we start is you should know the difference between creation and consumption. So in this case, we as developers, we work to produce the product, and there are users who basically use this product, and from our point of view, and also usually from users' point of view, we and they need to take a look from the other side. Like we, for the developers, we develop the applications or the websites or whatever else. We will. Christine's not there. Christine's back. Okay. Yeah, we as developers should take a look on the situation from users' point of view, and sometimes users should also understand the situation from the developer's point of view. Like just one example, currently I'm working on one project with the guy who is totally not from IT. So he, as the user, he asks me to create some things, but sometimes the knowledge and the view he has is totally different and sometimes unacceptable for the developers. Like some simple examples, he wants me to add some more features to the application we develop. I develop, but in programming there is one thing which developers do understand, but the users do not. And sometimes, this is the thing that if we have this the key rule, key formula we have, if we apply more features to the application, let's say application, but again that can be the website or any software you can imagine. So if we add more features to the code, to the application, there is more possibility that something will crash, or something will be broken, or something will not work as it previously worked. So in this case, we need to be very careful when we do some changes in the code, when we do some changes in our application, and sometimes we'll see it when we talk about project management, but some requirements from the users should be discussed, and there's maybe the common mistake for the beginners, but also for seniors as well. So we have the client asks us to do some things, to develop something, to add some features, and usually, sometimes maybe more sometimes than usually, the developers or the leads just say for the users ask something to develop, then the leads and those who accept all the terms, they just say yes, of course, everything will be done. So this feature, everything will be done. But at the end, it leads to disaster because some things may happen virtually with each other. Something maybe may not be done if other things are done, or on opposite way. So this may mix everything and make all the things more complicated, and this will take, firstly, more time, and secondly, if it takes more time, it will take more money, and more unstable solution at the end. So in this case, there should be the balance in between what the users want to consume, between consumptions of the users, what they want to have, and what we can produce to them. So these are the things we need to think about during the development. So if you have the code, you've written the code, and you want to add some new features there, then sometimes please know that it may affect the things that are already done. It's just for future to not worry about these things so much. This is just a normal practice. Okay, so now let's switch to the next slides. And now let's move to Java. We'll discuss some design principles, main benefits, technology stack in Java, Java virtual machine, execution of Java programs, and which Java version to use and which ID to use. Why do we study Java here? First, the key thing is that Java is one of the most popular programming languages in the world. It is used in many banks, retailers, insurance companies, utilities, manufacturers, also used in different SAP products, so you can apply your knowledge in lots of different places. Yeah, that's the programming language which can be used as the base for. First advantage is that you can use Java itself as a programming language, and also you can use it as the base for to be used in other programming languages. Java is heavily considered as very object-oriented programming language. So most of the approaches from object-oriented programming are used here, and so in case you want to study object-oriented programming, then Java is one of the best options to use and to learn as well. Then as I said, commonly used syntax, so it's if you read the code in Java, you can mostly should be easily understand what is meant in the code, and also to apply this knowledge in other programming languages like C++, because some things are the same in lots of programming languages, like loops, the syntax of the loops, the syntax of the exception handling, and so on. So in this case, Java has lots of advantages. So secondly, next, Java is statically typed. Comparing to JavaScript, we'll see how non-static languages look like. So, moment. So, Java is statically typed. So there are no dynamically typed variables like in JavaScript or Python. We'll see what does it mean. Then enormous different applications and softwares use Java as the main programming languages, like the web applications. You can build them using Java. You can run Java across desktops, mobiles, and embedded systems, so it's quite flexible on different platforms. You don't need to set up all the complicated things there. Like, don't need to set up tens of thousands of different softwares to run a Java application. You can we'll see what you need for Java, but that's quite easy to be used. Then many different libraries available for Java. You can find external libraries. You can also find you can also create your own libraries in theory. So you can find so many different things to apply in your projects in Java. Then regular updates and improvements. Java is improved, so that's the advantage, and in some cases that can also be a disadvantage, because some things are deprecated in newer versions. In some cases that may be as a disadvantage, but lots of I would say a lot of stuff you written, if you have written like 15 years ago, that you can still run them in current versions of Java virtual machine. also why Java is good for learning. It's heavily influenced by such programming languages like C++ and C#. As I already mentioned, it has like English type syntax, so most of the things can be understood from the namings, from the keywords like if, else if, try, catch, class, private data public, and so on. So these things are written in English. It's not like something like binary or something that you cannot understand. So one example. This is the father of most of the programming languages. It's called assembler, and here you can see how the code looks like in these languages, in this language. So that's a little bit more complicated to understand it than to understand Java. So in this case, Java is more modern to write the code on. Then you have lots of built-in frameworks. So in case you want to use a graphical user interface, GUI applications, or web development, there are lots of frameworks you can use to achieve your goals. It's relatively easy to find help in Java because I'll say not all the questions, but practically all the questions you are searching for, you can easily find the answer to them. So there should not be something which can't be the answer to which questions cannot be found in the internet, or if you ask for help to your colleague or me or someone else, there should be the answer for all the questions you may have about Java. And also many built-integrated IDEs to write the code on Eclipse or IntelliJ, open source tree, and so on. So lots of IDEs to use. Visual Studio as well. When JavaScript can be used building Android applications. So Java is the main language to build Android applications. So to write the code in them. Of course, Java web applications, software tools, scientific applications, games, and lots of graphical tools. All of these things can be written in Java. Then let's move on to language principles. As you know, Java is object-oriented language. It means nouns over verbs. It means that the behavior of the variable, as you know, depends on the objects placed under the corresponding variables, and the behavior of these variables, of these objects, are defined in the classes. As you know, there are two types of data in Java: primitive types and objects, or referenced variables. We can call them. So the behavior of these two types is different. As we know before, all the objects are built based on the object types. Reference types are based on the primitive types. So we can say that they are wrapped these in the in the objects, in the classes. So yeah, this is about the types and packages. The code is structured in packages, so we may have the same classes, the same interfaces, the same names of the interfaces in different package. So based on package name, based on different package, we may have different meaning of the classes or the interfaces or whatever we have there in different packages. Yeah. So then we have in programming, in Java, we have two types of the approaches. We have imperative approach and declarative approach. We can, so these are two different approaches used. If we talk about declarative approach, it's like multifunctional to just execute some commands and get the results, and this is mostly about SQL. Then we have another approach where we define the procedures, define the steps one by one, and this is called imperative approach. We can split it into different topics, different parts. The procedural approach, when we use the procedures, different procedures to execute the code, and object-oriented approach like in Java, where there are the objects, there are the methods in the objects, the attributes, and we have the behavior, which depends on how these objects are defined. So for example, you arrive at a red lobster, approach the front desk and say. So we have two different approaches to use. So the first one is imperative approach. I see that table located under the gun fishing sign is empty. My husband and I are going to walk over there and sit down. And the declarative approach would be just one command, table for two please. So this is one command. If we have imperative approach, then we have the description of all the steps done. So it means that imperative approach mostly describes how we do it, and declarative approach just explains what we want to do. So about the Java language principles, we have this thing that code and data can easily transferred through the network. So all the data can be transferred to the network. It's easy to try to find server or multi-tier applications. We'll see a little bit later what does it mean, and also it's safe. And each Java application is executed in separate sandbox, so it cannot interact with other machines. So if you have one application, then two applications will not face each other. And there are so many different features too for code access control. The main quote for Java is write once, run everywhere. So the applications can be executed in any operating system or hardware platform using Java virtual machine. So it means that have a Java virtual machine, as I previously said. You should not have something more specific to run Java applications. That's because of Java compiler, so it's a little bit different than the compiler, for example, in C or in other programming languages. Basically, it allows us to easily execute the code using Java virtual machine. And what else? Yeah, the performance of the code. So how you run the code. It depends on the machine, on the software, on the hardware, and the operating system your code is executed on. So the performance may be different if you execute it on one computer or in another computer. So the performance may be different. That's because of some key features of key built-in features in Java. Then yeah, there's standardized error handling. So errors raise exceptions, which are handled in a coherent way. Previously we talked a little bit about the exceptions. In this course we will also talk about them in a more aggressive, more precise way, and more advanced way as well. Then yeah, there's high performance. Java performance can be scaled by increasing of Java to machine resources. Previously we have not used it. So this Eclipse is not running, but yeah, so it's also possible. I haven't shown you this feature before, but for some programs that's maybe really it's maybe needed to increase the memory used, because by default, as I remember, Java programs use maximum of 2048 megabytes. Sorry, not megabytes, but megabytes of memory. But in Java, like when you run your program, here I don't have any programs in this workspace, but yeah, I will show you a little bit later. In case we want, we can change the memory to be used when we run our program. So in this case, it's very flexible, and it depends on the resources we have on our computers. Then yeah, the next one is static types. So past data types are checked during compilation. Yeah, so nothing. Again, we'll see how JavaScript or others or other scripting languages look like, because the concept there is different and I would say more complicated than Java. That's because in these programming languages the variables are not statically typed. So basically this will look like I will show you later, but just for now you to understand, we declare the variable somewhere in the middle, and we directly, so we do not provide the type. So as you know, in Java we must provide the type of the variable to be used, but in scripting languages just like JavaScript or PHP, for example, you will see that you can just basically create the variable in the middle, without providing the type of the variable, and then you will just have the variable. You can use it later, and from my point of view, that's really nice. So just you don't need to know the type. You can just declare the variable and use it. But the complicity here is that you declare the variable, you don't know. You know the type, but you know the type you expect. Yeah, you expect something to be used there, but it is not checked. Yeah, in fact, there may be something else. Yeah, you don't know, but sometimes there may be something else you expect. And if you have, and you may have the situation that you actually declare the variable somewhere in the middle of the code, and the type of the variable is not the same as you expected, and this will of course, this may crash your program if you do not handle the exceptions in a proper way. And this will not work as you expected before. So in this case, for static typing, this is easier to control, because if you type something, then you can easily check all the methods. For example, for the scripting types, for the variables declared in scripting programming languages, you can call the functions, call the methods, access the variables. You can write. So you can write everything in the code, but at the end, some of these variables it is possible. So from the code perspective, the code will be compiled and you can run the code, but during the execution, you can face something like the function is not available, the method is not available, or the variable is not available under the object. Some things may be missed, and this may trigger the errors. Also, this head for the variables, like in Java or in PHP, it is possible to just have the object, and you can during the program you can add some more attributes to the objects. Like in Java, you know that we have the classes, we have the attributes, we declare the attributes, so everything is declared, and until the end of the program, nothing will be changed. And comparing to PHP or JavaScript, all these things and also the functions may be changed during the execution of the program. And this is what scripting and non-static languages mean. In Java, everything is statically typed, and you can read and check the code before it is run, and be sure that nothing will crash. Nothing will crash from declaring point of view. Also dynamic execution. All the classes are loaded when needed for execution. We already had some things about it, but we'll also see it in our course. So what does it mean, and how can we use it, and what may be the problems here. Executable components can be gathered to the network. That's also possible, and interchangeable implementations. So using standardized APIs, it's possible to use different implementations of the same libraries. That's also depends on the libraries loaded. But we'll see what it means a little bit later in this course. Now let's move on to the Java technology in general. So Java is developed by Sun Microsystems, which now is called by Oracle. So it means that all the official information you are looking for in Java will be available, is available and will be available in Oracle website. So Java belongs to Oracle, and all the materials are there. Also, all the files, all the downloads can be found there in Oracle website. Three things Java technology is based on. It's Java programming language itself. So that's the text you write. Then the next one is Java standard API and other built-in libraries. So these are the codes, the classes we can use, the classes, the interfaces, and all the parts of the code we can use in Java. So this is Java library. This is Java library. All the key things are there. And development tools. So the tools which allow us to develop Java. and all this is bundled as two types of packages. So the first one is Java runtime environment, which allows us to execute the programs which are compiled standalone which are compiled standalone applications, applets, servlets, and so on. And then we also have Java development kit, which is needed to compile the code. So it means that these things are not compiled. So we need to Java code, we need to compile it, then we can debug it and also execute these programs, which are not built yet. So, for example, all the programs we developed in Eclipse. So by this point, you cannot actually run them without Java development kit, because these are not the programs yet. We just build them. At the end, as I mentioned it once, at the end of the course, you can export your programs, and this will allow you to execute your programs using Java runtime environment. So and Java is open source, so you don't need to pay. You do not need to get any special license to use Java technology. So everything is open source, and you can access it without any payment. It's developed openly in Java community process. No reality is to develop, run or use. So you have the access to all the libraries. As you previously seen. So we can go to the declaration of any class we use in Java, like the string or just an exception class, for example, and so on. We can easily access all the code here. So it's there's no such thing like if we have the code, then one moment, I think that for some reasons I accidentally calls or no, live stream I think is still here. Just let me quickly check. Okay, live stream is here, so nothing was missed. Sorry, I just was a bit scared that YouTube link is not open, but the stream is still in place, so everything's fine. So let's continue. Open source, again, it means that everything is open for us, no hidden code. So it's like there's no such code you use, like any class, for example, you use some class you use, but you cannot access the code of this class, so it's not possible. In Java you can access everything. This is why it's called open source. There is that some implementation is copyrighted. That's possible, but this is open source, so you can check everything. And this is the structure of Java platform stack, how it looks like. So you can see that at the top there is Java language. So this is just the text we write. So it means that all the Java code we have, we write. This is just, for most of the programming languages, it is correct that you just basically write the text. And using the IDE, you can easily see the structure of. This compiles your code in runtime, and you can easily see the structure of the code using IDE. But in fact, this is still the text file. And this is Java language. Then you have the tools. So when you download Java development kit on your computer, so I will show you how it looks like. So you have Java Development Kit, and you have the tools here under the bin folder. So, for example, Java compiler is here, then Java application, Java application itself is here, and so many different features, different tools, which can be used for, which are used for to develop the programs in Java. And then we have the development kit. All these tools actually also belong to this environment. And so here you have some deployment things, user interface toolkits like Spring and AWT. We already used for the graphical user interface development. Also some integration libraries, like we used Java database connectivity to connect our program to database. Image input output sound as well can be processed by Java code. Then for Swing there are beans library. There's beans library. For networking input output we used for example the scanner, just to write the code in console, and you can also get the output of the code also in console, and so on. Also other language libraries like math, logging, GR, zip, and so on. And also Java virtual machine, Java hotspot client, and server virtual machine. And this is, we won't speak more about it, but just to know how the platform stack looks like. This is simple Java. It's simple, but this is the main Java stack, and there's also Android stack. As I already mentioned, Android is written on Java, and there is stack used for Android, so it's a little bit different. There are lots of Android framework design features, the structure of the framework. There are lots of XMLs used to define the views, like strings like views, or the general structure of the application. So there are some additional things which are not always needed to build very simple applications, but are must-have to build Android applications. Like again, so many windows, views, and so on, used for mobile applications. So this means that there will be some more libraries, more core features, and so on. So also Bluetooth, camera to be also used here. So here you can see the summary of differences between Java Development Kit, Java Runtime Environment, and Java Virtual Machine. So the Java Development Kit is the tool to compile, document, and package your programs. Java Runtime Environment, this refers to Java bytecode, which can be executed, and Java Virtual Machine, that's the machine which provides our runtime environment, and where you can execute this Java bytecode. So Java Development Kit contains Java Runtime Environment plus some development tools. Java Runtime Environment itself, that's the implementation of Java Virtual Machine. Java Virtual Machine, that follows pre-notation, specification, implementation, and runtime interface Java. Alright, and yeah, so this is the thing that was not originally included, but this is what we have nowadays in 2021. If you talk about Java, there are some things you may notice when you read some articles or some things about Java. You may notice that there are some close relatives, related languages to Java. So these are the languages which basically come from Java. And yeah, there are some of these languages are interpreted by as a Java program, and some also are compiled to Java bytecode. So it means that we write the code in different programming languages, but at the end they all are compiled in the same bytecode. Quite easy. You write in different languages, but at the end you have the same result. And also compiled during execution as regular Java programs to improve the performance. Let me introduce these programming languages. So one of them is Clojure, and some modern dynamic and functional dialect of the Lisp programming language. All this also uses Java virtual machine. Groovy, that's a dynamic programming and scripting language. Also, it's related on Java. If we have time, we will go through some of these languages and we'll have some codings of them. Maybe let's see how much time do we have on this. Then Kotlin. Also started with time from JetBrains, the developers of IntelliJ IDE. Scala, static with type, also object-oriented and functional programming language. GRuby, an implementation of Ruby language, and GPython, which is an implementation of Python. Jython, which is an implementation of Python programming languages. I think that you heard about Python, very popular language nowadays. So Jython is the one which uses Java virtual machine. And yeah, what is Java API? That's the application programming languages, application programming interface, which is a list of all the classes that are part of Java development kit. So all the classes we have in this Java library, main library, and so this is included in Java API. It includes all Java packages, classes, interfaces, along with the methods, fields, and constructors. So everything in the base of our program. All these are pre-written classes that provide us the functionality to build the applications, to build the programs in Java. And yeah, some quotes what Oracle says. So get started quickly. It says that it's easy to learn. It depends on what you learn. There are so many different frameworks used by Java. Sometimes it needs time to understand all these things. Sometimes that's why I would say that it says that it's easy to learn. Of course, for those who previously worked with C or C++, that may look differently, especially about the pointers, because C++, that's also object-oriented programming language, but it has some differences. For example, in Java, there are the interfaces. We know that we have the interface in Java. But in C++ there are no interfaces, but there's such thing like multiple inheritance, which basically provides us most of the things which can be used using interfaces. but in Java we don't have multiple inheritance compared to C++. So that's about object-oriented programming differences. Also, the key thing of C++ and which is widely used in C++ is are the pointers. I will explain what the pointers mean in C++, but in Java there are no pointers. Java mostly object-oriented language, and let's say Java tries to implement the concept of the pointers used in C++ using the object references. Yeah, I will explain you a little bit later what does it mean, but there are differences in Java and C++ in the concepts of these two languages, so I will not say that it's quite easy to learn, but some main things are easy to understand. Alright, yeah, then we can write less code. Again, it depends. In some cases we can write a program which is 4 times smaller than the same program written in C++. That's possible, but again, it depends on how you write the code and what you write, how many libraries do you use. So there may be so many different libraries. If you reuse the code, if you write the code which can be reused in other places, then of course your code will be smaller. But again, it mostly depends on you, how you write, and what are the approaches you use. And yeah, it's also said that you can write better code. It encourages quick coding practices. I would say that most of the languages do this, and different languages have their own good practices. It depends, but yeah, it may be that it is possible that you can write better code in Java. And yeah, also there's automatic garbage collection, which helps us avoid any memory leaks. Yeah, that's possible. And also about some component architecture, which allows us to achieve it. Yeah, that's possible. And then develop programs more quickly. Again, it depends on which programming language we compare to. Because again, I would say all these things, it mostly depends on how developers write the code. Because different languages have different standards, have different best practices, but at the end, everything depends on how the developers write the code. I will avoid platform dependencies. That's what I already mentioned. Java is not platform dependent, so you can write once and run everywhere. That's I want to agree here that it is absolutely true. So you are not dependent on the platform. You want to run your program, and yeah, this also allows us to distribute software more easily. With Java Web Start software, you are able to launch your application with a single click of the mouse. So it's quite easy to do. Okay, right now let's have 10 minutes break, and after the break we will continue. Okay, let's move on. So now we can quickly go to the key points that are quite meaningful for developers. First of all, as I already mentioned, that's open source. It's really easy to see what the code means, what the code you use, because some things in some other programming languages, some things can not be accessed from the code. So you actually use something, but you don't really know, you don't really understand what you use, because you cannot really check the code. So comparing to these languages, Java is open source and everything can be found. And then Java compiler, that's quite easy to use. It's quite flexible, and it depends. As I said, can be used for other. So Java code can be compiled to the bytecode, which is the same as compiled in some other languages like Groovy, Scala, and so on. Java has core API, which besides libraries, there are many thousands of third-party libraries you can use here. Then Java memory model, it's about garbage collector, debugging API, and so on. So it's quite comfortable to use, because in other programming languages, some programming languages need to think about how to free memory, how to collect the garbage, and so on. In Java, you don't need to think about it. It is done automatically, so it's a really nice thing to use. Next, there's high performance, because as I said, it depends on the platform where the application is run on. Okay. Then the bytecode, it's openly defined, and it allows us to compile into Java the bytecode from other languages, as I mentioned, using Scala, Groovy, and Clojure, and Python, and so on. There are so many third-party tools to hack the code for debugging purposes. I think I mentioned it, not sure if for the whole group or for one student, about the so-called decompiler. So it means that if you have Java bytecode, you can also use some tools to translate the bytecode into the Java code, so you can easily read it as Java code, as text. So there are so many set intelligent IDs which can be used, so they can help you to understand the code, control space, all these things. Quite nice to use in Java. There's so many profile tools, open API for testing and debugging. There's backwards compatibility. There's no flag day for different versions. Like if you use different versions, it's not a problem for Java. In general, there are some things, but if you write the code, it doesn't mean that your code will be old-fashioned in 10 years, for example, and you will not be able to run it. There's maturity was innovation. And Groovy, Scala, Clojure, Kotlin. These are relatively new programming languages which are developed based on Java and can also be used alongside with Java. You can also find other reasons why Java now rocks more than ever. Yeah, there are some things, yeah, and the question maybe why Java didn't take the world, mostly that's the beginning Java applications were slow and less responsive comparing to native applications, and that's because Windows did take the world. Yeah, also I did not mention, but this course is originally built in Linux, so when you see some things here, for example preparation of workstation, it requires you to install Linux. If you want, you can do it, but we will not use Linux in our course. We'll use I will use Windows. If you have other operating systems, you can use them as well, but yeah, this course is originally built in Linux. And all the things you'll find here, most of the things, especially about the setup, these are related. These are built in Linux. All these tutorials. And yeah, this is also the case. Windows is the case. It's mentioned as the one which did not allow Java to take the world, because there are some things, like some pop-ups for some Java setups. Because in Linux, comparing maybe some small things, some comments about Linux. Basically, maybe not most of you do understand what Linux as the programming language, or not programming language, is the operating system mean. Yeah, basically for those of you who don't, I think that most of you heard about Linux, but not every one of you knows what Linux is, what this means, and what the advantage of this operating system. Basically, the most popular systems are, as you know, Windows, macOS, or Linux as well. But Linux is less popular, especially if we talk about some usages, because most of the companies use Windows, less of them use Mac OS as the operating system, but Linux is mostly used for development, and there are some key advantages in Linux, and the first one is the main for all the Unix systems, because in fact Mac OS is also Unix based system, but there are some restrictions in Mac OS based on some Apple designed features, but Linux is open source. Basically all the Unix, most of the Unix systems are open source, but Linux is free software, so you can install Linux without you don't need to buy any license to download Linux. Also, some things you can also see them from files, from the exercises here, like the setup. Most of the things, like you can simply type the command, and this will install you all the things you want to install. So it means that command based, you don't need to search for the thing you want to install in the internet. You can easily type the command, and this will download you whatever you want. So this is the advantage of downloading and installing the things. In some cases it's easier to do it in Linux. But yeah, of course you need to know what the commands to use. Yeah, comparing to Windows, which is mostly like user-friendly interface for those who don't know all these commands. You can see see here. These people can use, these people mostly use Windows or Macintosh, but Linux is mostly used by developers. And open source, it's maybe less. It's more secure. It's more secure and also, let's say, developers friendly. It's more friendly for the developers because, as you can see, all these things do not help us as developers to code. Especially when you need to update something in Linux, it's done in more friendly way for us. So okay, let's move on. And now we can see the graph of top programming languages in the world. So Java is mostly at the top. There's C language. C language. That's mostly, that's quite frequently used in Unix systems, and also that's mostly legacy. Because so many legacy code is written. There are lots of legacy code written in C language. So C++, C#, because C and C++ languages, they both can use the same compiler, with some exceptions, but they use this mostly similar compiler, same compiler. And Python is quite popular nowadays. Visual Basic Net for net applications is used. C++, I already mentioned JavaScript for web development. That's why it's maybe somewhere on the bottom, but in fact, without JavaScript, most of the web front-end things are built in JavaScript. PHP for web development is frequently used as well, maybe less nowadays. I use PHP. SQL for the database, that's quite interesting that you can see the unchanging curve for SQL. That's mostly because SQL is must-have language to access the database. For those who work in previous course, you already know that we access the database using SQL language and Swift. This is quite a new language. Becoming more and more popular. That's the modern language. A moment. That's developed by Apple, of course, and in Apple applications, it is frequently used. That's Apple, that's developed by Apple. JDK. Let's talk about Java Development Kit. So when Java Development Kit is installed, you have all these tools: Java compiler, Java command application which interpreted bytecode, so you can run the Java code using Java program. Javadoc, that's for documentation tools. GAR, that's the archiver for the process. And GDB, that's for Java debugging. And all these things are integrated and encoded in modern IDEs. So that's Java Development Kit is used for application tool. So there's application programming interface and all the core functionality of the Java programming language, from basic objects to networking and security to XML generation and so on. So you can find so many different so many different things to use from Java API. And yeah, it provides also the deployment technologies as WAR and GR files for Java App Start and Java plugin execution. Yeah, toolkits like Java FX Swing or Java-13-2 as well. So many integration libraries, Java database connectivity, and so on. Then yeah, Java virtual machine. That's what we need to have must have what we need to have to run our Java program, and of course to develop our Java program. Yeah, there's formal specification. That's the book that formally describes what is required of a Java virtual machine implementation, having a single specification that ensures all implementations are interoperable. Yeah, there's one actual implementation. It's a computer program that meets the requirements of Java virtual machine specification, component and preferably performed manner. And yeah, also specification instance of the Java virtual machine as the process that executes the computer program compiled into bytecode. So yeah, and shortly how it looks like. So first we have Java file, Java text, then we have the compiler which translates the text into the bytecode, and then we have Java virtual machine which is actually the same for all the operating systems, and then you can execute your program in every platform. So right here you can see that it doesn't matter on which software you will execute the program, the application. It doesn't matter for Java virtual machine, because it's done in this way. Yeah, Java virtual machine provides you it performs actually the following operations. It loads the code and verifies the code. Then the hotspot compiles code to native code and executes native code. And yeah, most Java virtual machines it executes bytecode and provides runtime environment for users. For us. Yeah, so it provides the definition of such things like memory area. It's basically the memory where the objects elements are stored. Class file format, register set, and garbage collection heap. Also fatal error reporting, and so on. And yeah, so this is the structure. We have the class folder. Now the class is class metadata. Stores basically the structure of the class. For example, runtime constant pool field and metadata, the code for the methods, and the two things which are quite important: the heap and the stack memories. So heap is the memory which stores the data during the execution of the whole program, and the stack that holds local variables and partial results in frames place and part in each method separately. So yeah, as you know, the stack is, for example, go inside the method, then you are in the stack, and everything what you declare inside the method, everything is placed here. You cannot access it. So what is defined inside the stack, you cannot access it from outside. The current stack, so it is only placed in the stack. Of course, if you pass the objects to the next stack, this will be available there. But actually, when you are out of the stack, everything what is not used from outside the stack, everything will be will be deleted, and you will never be able to access all these things. Comparing to the heap, memory, all the things located there will be available during the execution of the whole program, not only inside the stack. So here you can see some differences between stack and heap. So the memory that's for stack only used by one thread of execution, but heap is used during the execution of the whole program. This is what I said. You can access stack memory only inside the stack, comparing to the heap memory, which can be accessed, which is stored globally. So you can access it. And then memory management for stack, you know that it goes last in, first out. So you call stack. When you're out of the stack, then you go to previous. So the last one. So it means that the last stack you are in will be the first to be destroyed. But in heap, the memory management is based on the generation associated with each object. So in this case, there is no such thing like something is directly destroyed after some logic is executed. Yeah, the lifetime, then you are out of the stack, so everything is deleted. Comparing to the heap memory, it lives from the start to the end of the program. And yeah, the usage start memory only contains local, primitive, and reference variables to the objects in heap space. And comparing to the heap usage, that's so the object is created, it's always stored in heap space. So for example, in the object-oriented program we have static classes. So all the static attributes we have there in classes will be stored in heap memory. So it means that you have the class, you can access it at each moment in the program, and you will have all these attributes, all these variables stored there. You can access them, you can change them, you can store the values there, so they will be there, and so you can access them every time during the program. Comparing to the stack, so for example, create the object in the stack, so it means that you run the method. Inside the method you declare the variable, for example. You declare the variable, you use this variable inside your method, you finish the execution of the method, you go outside of the method, and then the variable is deleted and will not be available anymore. So this is as an example. And yeah, so there is Java internal structure. Several program counter register contains the addresses of the Java virtual machine. The instructions currently being executed. Native method stack contains all native method used in the application, and execution engine contains a virtual processor, interpreter with bytecode streams that execute instructions, and as I mentioned it previously today, so-called JIT, just-in-time compiler, that compiles part of the code that have similar functionality at the same time, and hence reduces the amount of time needed for compilations. All these things are mostly technical. We will not use them directly, of course, but these are the things which we actually use when we develop the programs. Yeah, as you know, the starting point is the main method, so we have this public static void main, and we have the arguments which we pass to the program. So As an example, we have command line. Don't be scared of command line. That's nothing like hacking and so on. For command line, we can actually just execute the commands. For example, the Java files can also be executed from the command line, and maybe just a quick example. So maybe right here. So quickly maybe copy paste some program and just hello world or something like that. And I'll just copy it. Cannot just write the code now, but we don't really need it at this point. Let's just hello world plus sorry, that's the byte class. Bytecode. Don't need it. Quick comment. Here it is. So if we change directory, so here we just execute the commands. Yeah, there is nothing. Special here. We just execute the commands. Command line is just the place where we type the name of the executable application. Like here, for example, we have the application. We can create our own application as well. It's not prohibited. And then we pass the parameters. And then we pass the parameters to the application. So it means that just for every program, not for Java compiler, but for any executable program, what we have, we provide the program name. So how does it work? So here I have the current directory. In some cases, it is important if you have something defined in the environment variables. It's not so important, but for example, so here I have the system settings. I have the environment variables. So right here I define them, and so define the path right here. And based on the definitions I have here, it doesn't matter if I'm in this directory or I'm in the other directory. I have some applications available globally, so it means that I can provide them here. And what does it mean? If I provide the name here, it means that it will execute the corresponding executable file. So in this case, it means that it will execute. So right here it executes Java-C. So in this executable file, and on the second position, we just have the arguments we pass to this executable file. Okay. So and right here we can execute other programs like Java. And if we execute Java hello world, this will execute the program. In addition, that should also work in this case. If I change the logic a little bit, so for example, we'll do this way. That should work here as well. So let me compile the file again. Okay, let me try to execute it from here. Yeah, so you can see it just prints out what I have provided here. So basically, how does it work? We have we execute the executable file, the application exe file, this one. Yeah. Then we provide the argument, which is acceptable by this program, and then we right here we actually it executes our own program, which is this one, and right here we pass the arguments, and again we use the space to provide new arguments, to provide the arguments. So we have the space here, and on the next position we provided the argument, which is actually passed to this array as the first argument, which is x, which can be accessed here. Okay. So in this case, don't be scared if you need to work with console. So just mostly console just executes the programs available on your computer. And yeah, if you go back to Java files, then you can see that now that we start with main program, all keywords before method are mandatory. So we need to provide the access modifier for our method, if it's static or not. Then the name of the method, then the returning type. If we don't have any returning type, then we provide void. Means that there is no returning type. Then the method name and the arguments passed to the methods. So inside the brackets we can write our code. So nothing special here. And then under the main method we call everything else. So that's the starting point. We start the program. If we start the program, it means that we call the method name. If we don't have the method name, it means that we cannot execute this program. Actually, the class can be used by other classes, but we cannot execute this class directly. This is what we said here. If the class is not used as the starting class, as the executable class, then we can skip using this main method. And this is how the whole structure looks like. We have Java source code. In this case, for example, that's called main.java. Then using the compiler, the code is translated to Java bytecode. Then, for example, let's see, network or file system is used. Then we go to class loader. And here we have bytecode verifier, just-in-time compiler, and Java virtual machine. So we verify the code, and then we go to the operating system, and now it's deployed to hardware. Also there is such thing like class path. For those who work with Eclipse and also with other IDEs, you may notice that sometimes there may be the problems with class path. When you in IDE, when you set up your project, by default it can be done automatically, but sometimes you must do some changes with the class path. So it actually means that this variable points you what is the path where Java searches your program in your classes. So that's the place where Java searches for the classes. And if it's not provided, then you will see a class not found exception. It means that the class is not loaded and cannot be found by Java. default path is dot. It means that path is current folder. Package naming conventions. We name packages in lowercase letters. In most IDEs, you'll face the warning that packages must be named in lowercase letters, and the structure priority starts from higher to lower. So first we have the package, then we have the subpackage. Again, those dots are used to separate the packages from the subpackage. So we have we can name it a super package. We have subpackage, and then if we use dots, then we go to the subpackage of the package, and so on and so on. It usually represents folder structure of source code and class files. So which Java package vendor? So there are several Java implementations, but Java implementation in fact is OpenJDK, maintained and developed by Java by OpenJDK community. Oracle, IBM, SAP, Red Hat, Amazon, Microsoft, and others, provided by different vendors, and repackaged and rebranded as Oracle SE, EE, ME, and so on. Red Hat, OpenJDK, and so on. So packages may be called Java runtime environment, libraries only for Java runtime, Java development kit, libraries and tools for compilation, testing, debugging, and packaging. And here you can see versions of the timeline of the versions of OpenJDK. Currently the newest one is Java-13. Just let me check the newest information. It should be Java-15. Yeah, that's Java-15. There are so-called long-term support versions. So it's Java 8 and Java 11. So these are long-term, and under these long-term versions there are some short-term versions which are more frequently changed and released. Also, you will see some deprecated code in Java. It means that this code will be available in the next few versions, but after some time the code will be deprecated. There is also possible you may find such code in the version in Java as well. And so which Java version to use? There are so many different versions. I just checked, but in March this year, so this month, there will be a Java version released. So if you want, you can update your current version to Java SE 16 this month. And which IDE to use? Again, in this course we'll use Eclipse. If you want, you can also use other IDE. You prefer IntelliJ or anything else, or source tree and so on. That's not so important. Different IDEs have their own advantages and disadvantages, but in this course we'll use Eclipse. So basically the course is mainly built in Eclipse. Okay, so this is about the presentation. If you have any questions, you can ask, but we have 15 minutes left, and before the next lesson I would like you to ask to set up the environment we'll use. So one moment, I will also do it. So first of all, what you need to do is you need to open Eclipse and the workspace. For some reason it was not open, but let me think. Yeah, I think I can use. Let me just for this course I'll create a workspace to not interfere with other workspaces. Moments, so let me quickly. Let me create the folder. Okay, so I will. Okay, that's not this one. Let me quickly put the folder. Normally it's only, basically you can create your own folder and launch the application. If you want, you can use the same we used before. So in this case, that's not so important. Okay, so here we have the workspace and we can start our development. So first of all, what we need to do is to set up our project. We need to download, you can go to, that's not mandatory now, that's mostly homework, just before next lesson to be ready to work with the project. So first of all, we have this JTM, you can download it from here. This is zip file, and this is basically the main project we will have here. So I will select here and here. Oh yeah, that's I think that's archive file. Yeah, I think that's the right one. Moment, that was okay, maybe let's create a new project. Usually this one. I'll name it GTM Java-13. I will use current SE and I think that's fine. And so we create the project and I will import now the archive file. I just download it. This one. And now it should be fine. And so here it is built in this strange way. Okay, so right now I will I will adjust it a little bit. So I will configure both paths. So I'll provide source folder. It's this one. This one I might use. Okay. So this is the source folder, and here we have the packages and resolution. Thank you, Alexandra. Mentioning it's okay, no, I will the final resolution. Let's Okay, maybe let's do it differently. Let's go imports from here. Okay, maybe. Oh, I think that was the right one. Just accidentally missed. Yeah, I think that should be correct. Okay. So now it's fine. And go to import projects and select not the archive file but existing projects into workspace. Yeah, this will build your project correctly. Yeah. Okay. Yeah, import existing projects into workspace, not archive file. And then here you select archive file and import the project. So right here you will have some errors. In my case I have a few of them, but in your case you may find more errors. That's because these errors are just character related. So in this case they're not important, but in your case I think you should have you will have more errors. That's because let's make something first. That's because there are some dependencies, and in this case you need to set up Maven. So this is the home task for you. I think for those who work in the previous course I mentioned about Maven, but not sure if everyone installed Maven, so please install Maven. I will share the link with you how you can install Maven. Oh yeah, so here it is in the chat, so I will share it again. So you can follow, for those who use Windows, you can follow the instructions here. For those who use Linux, you can directly follow the instructions from here. But yeah, you need to install Maven on your computer, so it requires you to do some settings in system environment variables. So you need to define the Maven settings here. So you need to have Maven home. Again, Maven home. This would be the place where you define where you place your Maven files downloaded. Also under the paths there should be Maven home, bin directory. So things, but yeah, you can follow the tutorial, and all these things are mentioned here. At the end, of the command line, that should be. We can execute the command Maven version. Yeah, Maven version. And so this means that Maven is installed. So it's already installed on my computer, and I can use it. So after that, yeah, you have two options. I think that was by default enabled in Eclipse. I think yeah, that's what you have by default. You can so once you install Maven on your computer, you can go to the project, and you can convert your project to Maven project. So in my case, that will not change much for me, because this is in fact already Maven project. All the Maven projects contain a POM file, and this is actually the file which points us what are the dependencies to be loaded. So as I mentioned, we have libraries loaded in Java, and we can have external libraries. So if we want to have more libraries, then we provide them this PRM file. So this is PRM XML file. This is the core of the project. There are some errors, don't worry about them. So in our case, these are not critical for us. Yeah, there are two types of error. If we have such error like X, this means that the project it's not a quite serious error. But if we have other types of error, and I'll show how it looks like. Let me quickly search. Yeah, so this type of error. So if you have such mark, such error, then this means that this is a serious error and your project will not be built. In my case, I can actually run something, and this will not. This should not crash. Okay, it's launching. Yeah, but that should not. The program should run. So there's the program. You can run it. No class not found exception. Let's unit test. I'll talk about unit tests a little bit later. But yeah, so once you imported the project, once you installed Maven, you should have. You can convert to Maven project. After that, you'll see Maven dependencies, which are mentioned in POM file. I'll explain it as well next lesson more deeply. But for now, the home task for you until the next lesson is to install this this project. Just import this project. So install Maven, and after that, you will be able to work with them. With the tasks in our course. So we have tasks here, so all the tasks are placed here. There are the files which can be used for the tasks you can navigate to do. Here you have the tasks, the explanation of the tasks. Also inside the code you will also see the things to do, what you need to do. So everything will be described here. Yeah, basically everything is located here. You can export it yourself. It will be just the first steps. But yeah, we'll go through all these things on Wednesday, and yeah, I will also explain what we need to do. But for now, just import the project in Eclipse or any IDE you use, and yeah, install Maven so you cannot have critical build errors. Because if you don't have Maven, if you don't have the libraries loaded, so it means that all these libraries you will have here will not be available for your project, and you will have critical errors in most of the files without these libraries. That's about it, and next time we will set up Git as well. So I will share the main repository. I will write the code in during the lessons, and also you will create your own Git repositories and share with me, so you can deploy your home tasks, the solutions for the home tasks there, and share it with me. But yeah, I will explain the schema we'll use next time. So for today, thank you for your attention, and meet you on Wednesday. Bye.